Okay, this is part 2 for section 1.5. So now we're going to look at graph functions using a reflection about the axes. So we're going to have horizontal and vertical reflections. And so with vertical reflections, we're going to basically begin given a function f of x again. And then we're going to get a new function g of x, and that's equal to negative f of x, and that's going to be a vertical reflection. Okay. And so basically we're changing all of our y values, our output values, and if it was initially positive, it becomes negative. If it was negative, it becomes positive. So it's going to be a reflection about or over or through, however you want to look at it, the x-axis. So if we look at our graph down here, our original function is blue here, and a vertical reflection would go over the x-axis, and we'd end up getting the green function. So, if we had this point here, it becomes negative, it goes down here. If we have this point here, it becomes negative, it goes down here. And if we have that point here, it becomes negative and goes down here. And so basically we're multiplying all our outputs by -1. And again, if they start out negative, if maybe this was our original, then it becomes positive, and then we get the blue function. So it can go both ways, from down below to up above, or up above to down below. Then we also have the horizontal reflections. And so basically, again, given a function f of x, now what we're going to do, the new function is g of x is equal to f of negative x. So we're changing the input functions, the x's. So in this one, it's a horizontal reflection. And so we're going to basically reflect about or over through the y-axis. So, we're going to go this direction now. We're going over the y-axis. And so our original function's here. So if we reflect over the y, it's going to come over here. If we have maybe this one, then it's going to reflect and come over here. And if we have this one, then we're going to reflect all the way, or I guess if we're here, we're going to reflect all the way over here. So it all just changes what our x value is. So, if we start out negative, it becomes positive. If we're positive, it becomes negative. And so that's how we're going to do it, reflecting across that y-axis. So basically, we're going to multiply all of our inputs by -1. So again, if it's positive, it becomes negative. If it's negative, it becomes positive. So in this one, we get to draw some more. And so we're given the toolkit function f of x is equal to x squared. And we want to graph g of x equals negative f of x. So the reflection over the x-axis, and h of x equals f of negative x, where we reflect over the y-axis. Okay, so again, we'll do 3 colors. And so let's draw what x squared is. F of x equals x squared. So if we plug in 0, we get 0. If we plug in 1, we get 1. If we plug in 2, we get 1, 2, 3, 4. If we plug in 3, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. And same thing goes over here. So 3 would give us a 9, and 2 would give us the 4, and the 1 would give us the 1. And so now if we try to draw this, it's basically a parabola. And so it looks something like that. And then this one, again, something like that. Not the best parabola, but it works for us today. And so kind of like we did last time, this time we have 2 graphs we have to draw, and so we'll have 2 domains and 2 ranges. So what is our domain? Well, our domain is going to be all x values, because this is going to keep going on and on forever to the left, and it's going to keep going on and on forever to the right. And so our domain is from negative infinity to positive infinity. Now, what about our range? Well, here we start down here, and we go all the way up. And so basically we have our point from 0 up to infinity. Okay. All right, well, what do we have next? Now we want to find what is g of x equals negative f of x. So let's change to, okay, let's make it red. And so let's say that's the red one. And so maybe I should do that. What we're going to do is we're going to change all of the values that are the y's to the opposite. So guess what? Opposite of 0, that's still 0. Now the opposite of 1 is -1. Opposite of this one is -1, and so on. So then 2 becomes 4, so 1, 2, 3, 4 becomes -4, and that becomes 9, and that becomes -4, and that becomes 9. And so we've reflected this across the x-axis, which is what we would expect. And so now we have this, okay? And so that's the reflection across the x-axis, so it's the vertical reflection. And so what is our domain? Well, our domain is still all real numbers, so negative infinity to positive infinity. What is their range? Well, this time we're going from 0 all the way down to negative infinity, or if we want to write it the proper way, it's going from negative infinity up to 0. And this time we include the 0 because that point is actually included. All right, so now let's change to, let's use our green again. And so this is going to be green. Now we're going to change all the input values. And so we're going to change whatever a positive x is becomes a negative x, whatever a negative x is becoming a positive x. And so our 0 stays a 0. And so now this one, it's going to have one input, it's going to become negative, and guess what? That means it goes over here. And this one comes over here, and this one from here goes over to here, and this one here goes to here, and this one here goes to here, and vice versa. And so I'm not sure, maybe we'll try to draw it here again. And so we'll kind of go to the side so we can see both lines. This isn't coming out quite so nicely. But what we end up with is it's the same as x squared. Okay, so we get the same shape, everything as x squared. And so that means our domain is from negative infinity to infinity, and our range goes from 0 to positive infinity, and that's a bracket. So that's how it works. And so we've reflected across going this way and then back this way, and we've reflected up, or basically down in this case, and to get to our negative f of x. And so those are the ways we reflect across the x and the y axes. All right, here's another one. Given the toolkit function f of x equals 1 over x, we want to graph g of x equals negative f of x and h of x equals f of negative x. All right, so let's go ahead and start and do our first one up here with purple, so 1 over x. And so what is 1 over x? Well, if you have your toolkit function, it's going to be basically shapes that kind of look like this. Now, this one, I'm not going to graph exactly. If we have 1 over 1, that's 1, so we have that point. But then if we have a half, that's going to be 2. And if we have 2, then that's going to be a half. Oops, that's not where 2 is. 2 is here. And so it's going to be basically something that is going to come down here. The reason why I'm not going to do it too exact is because I can't draw that well anyway. And so it's going to look like that. And the same thing happens here. So if we plug in -1, it's going to be a -1. If we plug in a -1/2, it's going to be a -2. If we plug in a 2, it's going to be a -1/2. And so then this one, kind of looks like that. And so that's going to be just the regular toolkit function 1 over x. And again, you should kind of realize what the toolkit functions are and kind of be able to draw them without having to do too much. So what is our domain? Well, we're going from over here at negative infinity, we're going blah, 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 up here. Now this keeps getting closer and closer to that 0, but it never touches the 0. So our domain is from negative infinity to 0, parenthesis, union. And now we're going up here, and it's not getting to 0 here, but it starts around close to 0 and it goes all the way out to infinity. So union 0 to positive infinity. Now, what about our range? Well, if we start at the lowest number, we're going from negative infinity, well, it goes to negative infinity, and it gets up here, and it almost gets to 0, but it never gets there. So we're going to go from negative infinity to 0, and then it kind of picks up over here, and it gets almost to 0, but not quite there. So we're going to start at 0, and then it's just going to keep going up and up and up, all the way up to positive infinity, okay? So that's just our standard function. Now what we need to do is we need to find negative f of x. So let's do that one in red. All right, so negative f of x means we're going to have a negative, if we think about this, that means it's a -1 over x, right? Okay, so we're reflecting over the x-axis. And so this one comes all the way down and we have that point. And then they say if we have that, that comes over here to about here. And then I'm not drawing this correctly. So that's half 2, so it's going to be a half negative 2. That's better. And then we have 1, 1, negative 1, 1. Let's erase that dot there so I don't draw through it. All right. And so then we have this point, which is 2 1/2, so it's going to be to negative 1/2. And so we're going to basically be drawing something that looks like that. Now this one does the same thing, except it reflects over here. So we're going to get something really close here. And then at the 1, we're going to have this. And at the half, we're going to have the 2. And at the 2, we're going to have a half. And so it's going to come down. And again, get really close. Now these should be equal, but you know, with my drawing, it's about as good as we get. All right, so this is how we're going to do this one. So what is our domain? Well, our domain, it's going to be, you know, from negative infinity up to 0, and then from 0 to positive infinity. So negative infinity to 0, union 0 to positive infinity. What is our range? Well, our range is going from negative infinity to 0, and then 0 to positive infinity. So just like basically we had before. Okay, but the shapes are on the opposite side now. Now, what is going to be our f of negative x? And so what we're going to do is, this one we just changed the whole thing. We just put a negative out here. This one, we're going to plug in a negative for our x. And so if we do that, basically what we're getting is this, okay? And guess what? That is the same as negative f of x in this case. And so, actually I should have changed the color here, so let's do that. Let's make it a green again. And so that's going to be 1 over a negative x. And these two are the same, okay? And so that means we have, now if we think about it, we could just go ahead and do the reflection. This comes over to here, this comes over to here, this comes over to here, and we're just reflecting about that y-axis, and that's all we're doing. And here, we're going to reflect over to here. This one's going to reflect over to here, this one to here. And so basically we have the same overlay. All right. And so that means our domain and our range are going to be the same. And then we have here from negative infinity to 0, union 0 to positive infinity. And so one time we reflected across the x-axis, the next time we reflected across the y-axis. And both ways, no matter how we do it, because of the way 1 over x is, we end up with the same f of x and g of x and h of x looking the same, okay? So that's another way we can graph going over the x's and the y-axes. All right, so this one, we want to reflect our function f of x equals absolute value of x minus 1 vertically as well as horizontally. All right, so first off, what we really need to do is we need to graph what does f of x equal x, absolute value of x minus 1. We have to figure out what that one is equal to first. Now remember, this is, we can think about this as, this is like your f of x, and so what did we do here? If the absolute value is our original, what did we do? Well, we subtracted 1 from this here, and so our h is equal to a positive 1. And so that means we're going to go right 1. And that's all that the original function here is. And so we had to do a transformation to get our original function before we could even do anything. And so our original function, what it looks like is something like that. And so let's go ahead and draw it in both things. That's the original. And now what we want to do is we want to reflect it vertically, and this one we want to reflect horizontally. So we can change maybe to red here. Well, vertically means what's up here is going to go down here, and what's over here is going to go down over here. And so basically now this one gets reflected to here, 2 gets reflected down here, that gets reflected here. This one stays the same. This one gets reflected here, here, here. And so now, oops, we can't draw a straight line. So now we have the graph reflected vertically looking something like that. Okay, so it's a vertical reflection. So we moved everything down is what we did. Okay. Now horizontally, remember we're just changing the positive x for a negative and a negative for a positive. And so really what we're doing here is we're taking this value and we're going to move it. And now we're not really, the x-axis has changed basically. We have to kind of say it that way because now this isn't the x-axis. We're not going to reflect all the way completely how it looks. You know, it's here, and so this goes 1, 2. So we go 1, 2. This one goes here. It stays there basically because it's right on the y-axis, I should say, not x-axis. And so this one goes 1 over. Oops, what happened there? And so now this one goes 1, 2, 3. So it goes 1, 2, 3. This one goes 1, so it goes over 1. Now this one goes over 1, 2, so it goes 1, 2. And this one goes over 1, 2, 3, 4, so it goes 1, 2, 3, 4. And so that's how we're going to have to look at it. And so now, when we've reflected it across the y-axis, we have this. And so, you know, this one was reflected all the way over here, and this one reflected this way. So here, you know, we're going to there, and this one, we're going this direction. So kind of reflecting over that y-axis, and so it kind of looks funny, but that's how this one is going to look. And now again, you know, we still, this point here, it doesn't change, so that's going to be common to both graphs here. Okay. Now, if we wanted to, we could show what this does. Now, with vertically, you know, we had f of x. And so then to get the vertical reflection, we basically had to take minus f of x. And so what does that do? Well, that just says, okay, we're going to take minus the absolute value of x minus 1. And so we're going to get whatever that is, and we're going to change the sign, and that's what we've done here. Now, when we do the horizontal, we have f of x as our original, and then we're going to go to f of a negative x. And so we're changing it to a negative x. And so when we plug in a negative x here, that's going to be a negative x, and then it's going to be minus 1. And this is what the function actually would look like if we had done it and changed it and actually put those negatives inside here. Now, we knew that when we did a horizontal, we were changing the x values from positives to negatives and negatives to positives. So we knew we were just reflecting about the axis. And so we just drew the graphs as they were. But if we needed to do points, we could do points as well if we thought about what the vertical was, changing f of x to negative, and here changing the x to a negative. Okay. Now we can also do the tabular changes, and that's kind of what I was alluding to here. We could do tabular by plugging in values here, but this one, they give us the initial table, and then all we have to do is get out the new tables basically from it. All right, so we have the negative 2, 0, 2, 4, and 5, 10, 15, 20. All right, so if we're saying g of x is equal to negative f of x, well, that one, what does it do? We're changing the y value because we're going to start up here and we're going to reflect across that x-axis and go down, okay? Or if we're down, we're gonna go up, depending on what our graph looks like. So here, what does that say? Well, that means our x values don't change, and so that's gonna be a -2, a 0, a 2, and a 4. But now all of our f of x's change to negative. So that becomes a -5, a -10, -15, and a -20. Okay, and so that's what this does, is it changes our f of x to the opposite. Now this one is going to be a horizontal shift because we're changing the inputs. And so that means our outputs basically stay the same, but our inputs are different. So this means 5, 10, 15, 20, those stay the same, but our outputs become the opposite. So that -2 becomes a +2. The 0, well, that's still 0. Then +2 becomes -2, and 4 becomes -4, okay? And if you would plot this, I believe what it's going to be is the right one here is a line that goes like this, and then the other one is going to be a line that kind of goes like this, okay? And so that's what's going to happen there. So those are going to be your reflection. Actually, that's, oops, that one's not correct. Let's see. So our x's stay the same. So we had -2, 5, and now we're going -2, -5. Yeah, I think that's right. All right. So that's -2, it'd be -5. Okay. 0, 10, and then 2, 15, 2 negative. Got that right. It's gonna, oops. That one's not going to be right. This one should be right as far as how it works, because it's going to be reflecting across this one, and so this original is going to be different. So that one is correct, but let's just erase it, and we'll because we're not really drawing graphs on this one. We're just kind of just plotting points. That one's easier to see because it kind of goes up and or down and to the right, and this one's going to go. From here, it's going to go, actually it's going to go down and to the left. So that's how it would actually be. So it's going to be, so a -2, -5. So it's going to be way below the axis, and it's just going to go keep going down. Whereas this one, the 2, 5, and so a -4, 20. So it's going to kind of do the same thing, but it's going to be higher up. So the shape will be the same. It's just going to be where it is in relation to the x-axis. All right, so that's what I have for part 2. I'll come back with part 3 shortly.